we have learned about homogeneous mixtures. Homogeneous mixtures, like in this case salt with water, salt plus water. And why do we call it homogeneous? Because the components mix thoroughly and the boundaries of the component is not visible. And at the other end we learned heterogeneous mixtures. And this heterogeneous mixtures are, like in this case, it's oil plus water. And here the boundaries are visible. The components are visible. The boundaries between the components are visible. Now between these two, homogeneous and heterogeneous, we have another set of mixtures, and that is suspensions and colloids. Today we will learn about these mixtures, the suspensions and colloids, which lie between this homogeneous and heterogeneous mixtures. Now we'll get into suspensions. Here is a picture example of suspensions, like muddy water is an example of suspension, and chalk in water is also an example of suspension. In suspensions, the particle size are quite large. We have large particles and they can be seen very easily at the naked eye. Here we've drawn a picture of a suspension. It's a heterogeneous mixture. Now why do we call it heterogeneous? Because the particles can be seen with a naked eye. And it is not stable, because after some time, if you have this muddy water and leave it off for some time, you will see that all the mud begins to settle at the bottom while the liquid remains on the top. So suspensions are not stable. They're heterogeneous. They are not stable. The two components separate one from the other. And the example, to repeat, of suspensions is muddy water, chalk and water. The suspensions also scatter light, which means if you pass light through this, if you have a torch like this, if you have a torch and you pass light to it, this scatter light, and hence you can see a nice beam of light passing through the suspension. So the particles of suspensions also scatter light because they are large enough to scatter light. Between solution where the particle size is less than 1 nanometer, and here we have the suspension that we just learned, where the size of the particle is more than 1,000 nanometer. And between these two, this and this, we have the colloids. And by now you would have guessed the particle size in colloids is between 1 nanometer and 1,000 nanometer. So colloids are mixtures where the particle size lies between solution and that of the suspension. And examples of colloid is blood, which consists of the plasma with the cells, with the little cells all over. Here there are little cells of blood. And also milk. Milk is an example of a colloid. Now unlike the suspension, the colloidal particles do not settle down. So colloids are very stable in nature. But however, they are heterogeneous. They look homogeneous, but they are heterogeneous. And then in the next slide, we'll see the scattering of light by solutions, colloids and suspensions. So just to summarize this, we have the solutions where the particle, the whole thing is homogeneous. It's very stable. The solution is very stable. Example, salt plus water. The particle size is less than 1 nanometer. Then we have the colloids where the particle size is between 1 nanometer and 1000 nanometer. Example, blood, plasma, plus cells and the milk. It is heterogeneous, although it appears homogeneous, but it is heterogeneous. It is stable. The particles do not separate out. And in the end, we have the suspensions where the particle size is much larger, more than 1000 nanometer. Example, muddy water, chalk in water, and this is not stable. Suspension is not stable. After some time, the mud would settle down, and it is also heterogeneous. Here we learn about the Tyndall effect. In this we see there is light rays, that's light, that is passed through a solution, colloid and suspension. And there is a clear difference. The path of light through a solution is not visible. Here, not visible. It is only visible in a colloid and a suspension. And why is that so? Because in a colloid and suspension, the particle size is large enough to scatter light. The particles are large and they scatter light. But in a solution, the particle size is very small, is less, and they cannot scatter light. This property of scattering of visible light by colloidal particle is called Tyndall effect. Here is an example in this picture of Tyndall effect. You can see the ray of lights coming into the trees, and this is because we have here particles of water, and these particles of water scatter the light. Now the water enters into the atmosphere because of transpiration. The leaves they give out water, and these water molecules then float in the air and they scatter light. So this is an example of Tyndall effect in a forest. The colloidal particles are water particles given out by leaves during transpiration.